I'm really happy to be able to show you some of the things that we do and also hopefully teach you something new about crowdsourcing. And I can try to make it a little bit interactive. I'll ask you some questions, but if you're too sleepy or don't feel like answering, don't worry. So my name is Maciej, and I work at Rainforest, where we use lots of crowdsourcing to make our product work. And I'm just curious, have any of you used something like Mechanical Turk or Crowdflower to get some data, some labeling or something? Awesome. Can someone share like what have you used it for and what were the kind of problems that you found?
My biggest challenge was no matter how well I felt I specified the task,
Right.
just never got done the way I sort of wanted. I spent more time trying to specify the task correctly.
Right.
I may as well have just basically done the thing myself. But
Right.
I didn't persist, so.
So that's not a planted person, but it's exactly the kind of answer that I'm hoping to answer with the talk. So the problem was that the workers don't always follow instructions exactly, and sometimes it seems like it would be faster to just do it yourself rather than asking other people to do it. So I mean, if you still have other problems, I'm really interested in this topic in general. So please talk to me afterwards. But okay, so. There are three technical parts of this talk. I will tell you about the kind of data that we gather and what we do with it, how we model the data, how we kind of understand it, and then how we deploy it, how we can actually use our understanding to make the product better. And there's also a slightly less technical part of the talk about empathy, because as we found out a while ago, there are many things you can do to improve the quality of your crowdsourcing sort of micro-task workers that are not necessarily technical, but I think it's extremely important. And there are also a few pictures of puppies later on. So the first part is the data. And to tell you what the data is, I have to tell you what Rainforest does. So we basically provide quality assurance as a service. So if you're a sort of a modern software development company, you want to deploy multiple times per day. And of course, you have your unit tests, but you also need functional testing. And traditionally, if you deploy once a month, you have a QA team that does the whole release testing before it goes to production. But if you want to do it multiple times per day, there's no time for that. So Rainforest allows you to do this kind of quickly and get integrated into continuous delivery. And because we deal with humans, we have to verify what they do because of these problems that were mentioned before. So specifically, I'll just quickly describe what customers do, what workers do, and then what kind of problems we expect and we observe. So what a customer do is this. They basically write in plain English what the tester should do. So it says something like, go to a specific URL, look at the page, and does it look fine? Like, because it's English and because humans are reading it, you can basically write whatever you want. In this case, we are testing Rainforest using Rainforest, so we want to check whether our blog is fine, and that's the test that we wrote. It's just one step. There can be multiple sort of steps. And then a worker gets that. They get the instructions on the top, and on the bottom, they see a virtual machine. So it's a terminal into a virtual machine with the sort of the right browser version and so on that people want to test on, and then they follow the instructions using the terminal. So the kind of problems that we might have are, first of all, the testers might not understand the instructions. Not all of them are English speakers or native English speakers. Some tests are badly written, so that's kind of one source of potential problems. Even if they understand the instructions, there might be some ambiguity in what they are expected to do, and they might not sort of know what is the right thing to do in a scenario, even if they understand it. And finally, they might just not want to do the right thing. They just want to minimize the time it takes them to complete the task and just get paid. And this is the thing that we try to counter. And there are many potential solutions for this, as I already sort of alluded to at the beginning. You need to make sure that your workers are trained, that you set up the incentives correctly. You can track the reputation so that to trust people that you know are good more than new people. You can ask multiple people to do the same task and look for consensus. And finally, you can also detect bad work from input patterns. And that's the topic of today, and it's based on a paper from 2011 where they proposed this kind of approach. And it works well enough. So the kind of data that we capture, first of all, as I mentioned, everything happens inside a virtual machine. So all the activities of workers are tracked. So their mouse movements and keystrokes and network traffic and so on. And then we have labels. I'll tell you later how we got the labels. But we know that for each step, there's a bunch of activity. And we know that it's either lazy or not. And so, just one more thing before. This is the kind of thing that we might see as admins after someone completes a test. So this is a login page to Rainforest with mouse traces overlaid. So you can see that the tester clicked on the address bar, probably pasted the URL. There's probably some information about pressing enter. Then they clicked on email address, pasted that, and password, and then logged in. So that looks like a reasonable piece of work. Assuming the instructions were log into the website, they did the right thing. So from this kind of data and given the labels, what kind of features would you think of if you just say, okay, I'm just going to put it into random forest or whatever? I would need a feature vector, a bunch of numbers. Any takers?
Time taken.
Yeah, time taken.
Can you track where they're looking at the screen?
It would be awesome to have eye tracking, and I mean it's kind of an idea that I'm thinking of, but no, so far we're not doing it. We could just try to approximate it with the mouse traces, but yeah, no, we haven't done that yet. But yeah, it's a potentially good solution.
Time between different interactions.
Yep.
An interaction is
Right.
a bit of a difficult one.
Of course. Yeah. So time between like clicks or keystrokes and stuff like that. Yeah. So I mean, you got a lot of it. So based on mouse movements, you can also look at speed and acceleration. You can produce like histograms of different speeds and so on. You can see how big the spread is. So if someone just clicks and then tries to go to the next step, they probably have depending on the task, they might have a different profile. The number of keystrokes, like we can look for special keystrokes. So if someone is asking to paste something in, we can look for Command V and so on. And also look at network requests because everything is kind of captured in between. And then, of course, you need the labels. And this is one of the biggest pains of this whole approach. And at the moment, all our developers get an email once a week with a bunch of links saying, hey, label data for me. And they go to our admin interface and click, yes, this is good work, this is bad work, and so on. And this gives us enough to do training. And the interesting part about this is how to select data points to label, because we have like tens or maybe even hundreds of thousands of data points every week, and we only have 20 developers. And if you ask them to do 10 labelings per week, that's already kind of pushing it. So we can only label a tiny proportion. So we started with completely random selection. Then once we got an MVP that was giving us results that we felt were good enough. And then we started doing this split where we took 50% of things to be labeled still randomly, but in the second 50%, we took the worst offenders, the worst work according to our newly trained classifier. And that was cool because that allows us to, first of all, verify whether the lazy work that's being found is actually lazy. It gets more visibility to human labelers. But it also has problems because labeling data is useful not only to generate training data, but also as a measure of health of our system. And because of that, we're going back to completely random selection because now we have a biased sample and we don't actually know, well, we know stuff, but we're losing an important metric. Right. So just a note about data balancing. I mean, you probably all know this, but in general, different algorithms deal differently with unbalanced data. Some of them are fine with it. Like if you use boosting, that's probably OK. For some others, it might not be. And there are different strategies. In our case, the data set is unbalanced because majority of people are actually doing the right thing. And there's only a tiny proportion that are being lazy. So I looked at these different strategies, and we actually had some balancing strategies at first. So there are two simple things you can do. First of all, you can throw out some data. So if you have a bunch of blue points and orange points, and you have many more blue points, you can just throw out some of them and not use them. Obviously, the disadvantage here is that you've spent all this time labeling your data, and now you're just throwing it out. So that's it's a bit painful. There's also super sampling, where you can do kind of the opposite, and you can just duplicate the orange points. And there are different strategies instead of duplication. You can try interpolating. You can sort of try finding clusters and then subsampling based on like cluster centers and all this kind of stuff. But just try being naive. We kind of continuously reevaluate our pipeline, and we at some point found that actually we don't need balancing. If we, as long as your metrics are good, you don't just use plain accuracy, you like precision recall or balanced accuracy. If your pipeline works with no balancing, that's probably fine. But I mean, it depends on the scenario. It's just something worth thinking about. So our model is a binary classification run on forest. It's pretty straightforward. It takes a bunch of these features that I described and has a bunch of labels. We get training, and that's fine, except now we have this classification per step. So when I showed you this example, there was just one step, go to a website, see if it looks okay. But there might be multiple steps, like log in, create an account, I don't know, update your profile or something like this. Each of these is a separate step. And we get classifications per step at the moment, which is not ideal because we actually care about the whole job. So we have a second classifier. If you just don't have enough machine learning, then make more classifiers. That takes output from the first one and then does some aggregation and some additional features on that, and then gives you a label for the whole job. And there are probably better ways of doing this. But for us, it's important to be kind of flexible and to be able to change things quickly. So for now, we trust the step classifier. We don't quite trust this one yet. And there's this nice analogy of this whole agile methodology. So if you want a vehicle to travel, instead of like designing a car from scratch, build a skateboard, like stick some wheels to the board, and you have a starting point, and you can build a bicycle and a motorbike and so on. So that's what we have for now, but there are probably smarter ways of doing the same thing. Probably going from all these primitive features straight to classification of the whole job. Okay, so that's deployment. A while ago, I thought I had my IPython notebook, and I had my classifier, and it had good enough performance, and I thought, great, sort of my work here is done. But then people said, okay, that's awesome, let's just use it. And like, how do you do that? You can just ship an IPython notebook and hope for the best. So what we needed was some kind of microservice. We didn't want to put it in our main application, so we need to be able to accept some HTTP requests, process the data, get the classification, and return back a bunch of JSON. It should be sort of fast enough, and we also want to be able to tell which model is being used at which time. So we sort of retrain every so often, and if you retrain, you might iterate on features, you might change the feature vector, and that brings a bunch of problems if you do it naively. In particular, when you think about changing your feature vector, you might make it shorter or longer, and then if you use your code needs to match the classifier. So if you use the wrong data for the wrong model, you'll get an error. But even worse, if you change your feature vector in a different way, so that semantic meaning of the feature changes, but the format doesn't, you might still get a number, but it will be wrong. So we want to avoid this kind of stuff. So as I said, we have main application communicating with our prediction service. There's also a database behind the main application, and that's basically all you need for the day-to-day operation. But for training, you probably want something else, because otherwise you'll have to send a whole bunch of data kind of through it indirectly, and that might not be ideal. So you might want to do that, but don't do that, because I mean it's kind of general good practice for creating microservices to never have two different applications talking to the same database, because then if you end up changing your schema, you have to update two things at once, and it's just a world of pain. So there are different ways of doing it, but we decided to do something really dumb, and we just train locally. Like, if we had to retrain multiple times per day, that probably wouldn't work. But once a week, once a month, depends. It's completely fine to do that. You just get a dump of your database or connect to it or something. Right, so we have an API. We use Flask because it's really nice and easy. And we start accepting requests, a bunch of JSON data, transform into NumPy, pass into your scikit-learn estimator, and then get back, transform back to JSON, and return. Do you know what this is? It's a pickle. So the question is, in all this pipeline, like HTTP requests to scikit-learn and back, you need to have the scikit-learn, like a trained estimator in memory. And how do you do that? you could do pickle, but that's usually not a good idea. First of all, like joblib might be better for this particular scenario. So joblib is something that's shipped with scikit-learn, and it's just very efficient at serializing numpy arrays. So it's great for classifiers. But there's a whole bunch of non-implicit assumptions that you're making when you use pickles. And there's a great talk from PyCon 2014 if you're interested in that. But basically, the arguments against joblib and pickle are kind of the same. Is that it's difficult to add versioning, and you have you don't directly control how it's being serialized. And also, if you try to deserialize untrusted pickle, don't do it. It's basically leads to remote code execution. So you have to be really careful. Additionally, if you look at scikit-learn's documentation, it tells you how to do these kind of things. So it says that it's good to not only serialize the trained classifier, but also the data, the version of packages that you use with it, performance numbers, and so on. So then when a new version of scikit-learn is released, they are not necessarily backwards compatible, so you can just retrain and get a new classifier without figuring out, which data did I use for that, is it still performing well, and so on. Yeah, so that's why it's important to keep track of all this additional metadata. And that's also why we released this tiny package called Destimator. It's like described estimator, and just you give it a classifier with all this metadata, and it figures out a bunch of things on its own, and then gives you a zip file that you can put on S3 or wherever. It's not perfect. It doesn't do anything to solve the security concerns, so you still have to make sure you only deserialize trusted things, but it makes some things a little bit easier. Yeah, and it's only basically it's only being used by us at the moment, at least as far as I'm aware. If you would like to use it and you need anything, please let me know, and I'm really happy to make it better, to make it more general. OK, so the other part of the talk is how to make sure that your workers are actually doing the right thing without being this bad cop and trying to catch them and ban them from the system. And by the way, the pet project for this classifier for us was Robocop, like this robot that tries to find bad people and eliminate them. But then we realized that it's a bad way of thinking about it, and we do this instead. So first of all, if you request work on Mechanical Turker, spend some time doing it yourself, because that gives you so much insight into how your tasks are listed and which tasks are more likely to be taken and which titles are appealing and all this kind of stuff. So that's really critical. Also give people ways to talk to you. So it depends on what you're doing, but in our case, we've been using Mechanical Turk for a few years now, and we have kind of reputation with the workers. They kind of know us. They know that Rainforest gives sort of tasks quite often, so I can rely on them and so on. And it's really important to foster a community and to actually give people ways to ask questions. They might be well-intentioned, but if you suck at training them, they will still do the wrong thing, and it's not their fault. And finally, puppies, as promised. This is my dog. She's called Whiskey, and she's a border collie. And that was a few months ago. She's 7 months old now. But the reason I'm showing you that is when I got her, so border collies are really smart dogs, and they're really they're fun. But if they're bored, they will get destructive. So you need to give them stuff to do. So before I got her, I started watching YouTube videos on how to train your dog and kind of different tricks and so on. And one of the things that are really cheesy but really stuck with me is this idea of setting them up for success. So if you have your small dog and you're training them to do something, let's say you want to train them to come to you when called, you shouldn't start with having the dog 100 meters away and then expecting him to come to you, because they won't know what to do. Be really close and say, just make a gesture to make it really obvious, and they will come over, you give them a reward, and you repeat this many, many, many times. Once they master that, you take a step back, increase the distance, and do this over and over. And eventually, they learn the difficult thing. But it's kind of the same with humans. I mean, teaching humans is not the same as training dogs, but some of the same principles apply. I know that when I'm learning something, it's much easier to kind of deep learning. Like if you understand a little bit about sigmoid functions and how backpropagation works, you kind of take it step by step, and then you get to the whole idea. But if you read, one of the classic papers straight away with knowing nothing before, you're going to have a very hard time getting it. So that's basically what you have to do with workers. Oh, and this is Whiskey. More recently, she managed to successfully shred my banking bills.
Oh.
Good dog. Right, so set people up for success. Have some kind of training regime to and monitor how they do, and yeah, teach them to do the right thing. To do that, you need to have clear rules, which is not always easy. Even it even took us a while to figure out what it actually is we want people to do and how to behave in all different scenarios. Communicating it is even more difficult. And then basically treat workers as not as commodity, but as a community, as a bunch of humans that you can communicate with and train them, and you can do all these things that you do for customers, like lifecycle emails and analytics and all these fancy things that are actually really useful. And give them feedback and listen also to what they have to say. And also some overall limitations of what we do. So data capture most of the time works, but sometimes it doesn't. And obviously, if it doesn't, our classifications are wrong. And there's lots of effort in labeling the data. So there's probably something smarter we could do, like active learning or maybe semi-supervised, to make sure that we're labeling the optimal set. But then again, we get into this problem of not having reliable analytics. We could also do this meta thing where we would build a system for workers to verify work of other workers. And that would be pretty awesome, but it also has a bunch of trade-offs and problems that we haven't yet figured out. And yeah, it's a great approach, and you should definitely do it, but think about what you want to do first. If you start with, there are things that you can probably start with that will give you much more payoff, for sort of more bang for the buck. And this is basically it. ML is still useful, and it's an amazing tool to solve your problems, but don't always jump to it. Thank you. Questions? Yeah.
You just spoke about serving the models
Mhm.
and building this Flask application. Do you know any open source solution for this? Because it's a very common problem in machine learning world.
Right. So
Do you want to deploy your model?
I don't know open source solutions. I know there's YHat is a company that provides this kind of service. I haven't looked into it that much, but it seems like, yeah, there should be something like this. I'm not aware of it. Like deploying, maybe not models, but
You can just open source your solution.
yeah. So Destimator, the thing that we have, is open source. So you can upload. Basically, you give it a.
The Destimator also is responsible also for serving, or it's only the serialization part of?
It is only the serialization. Okay, I mean, we can think about it. If people think it's useful, I'm definitely up for doing it. It seems like it's maybe not that useful because the other parts are, it's basically a Flask API, deserialized model, and then put NumPy data into it. But yeah, I'll consider it. Yeah.
At the start, you were talking about the binary classifier
Mhm.
you're using. Where did you get your initial fraudulent or lazy? How did you initially work out what that looked like?
We just got it from humans, so from our developers. I mean, we used to do it even before we started this whole machine learning thing, just for verification, just trying to catch bad workers and basically prevent them from working further. And so when we started this, we already had a little bit of data, but we needed more to make it work well.
What did the numbers look like as sort of percentage of lazy work?
All right, so good question. I think it's about, well, last time I looked, and that was while we were still doing the balancing thing, it was about 100 to 1. So about 100 good work samples to one bad one. But it probably changes because we also iterate on the training, and like it changes over time. But yeah, it's something I should actually know.
Over time, when you define a bad worker,
Mhm.
is it somebody who's been consistently bad over time?
That's a good question. It's kind of an undefined problem. So we don't do on-off. That's pretty unfair because, for example, there might be some problems with our virtual machines. They might not be able to connect, and then they just fail the job, but it's, again, not their fault. So we try to be kind of lenient, and we have like a sliding window, and if they cross some threshold of badness in this window, then they get banned. But then they can also talk to us, and they say, hey, I think I was banned unfairly, so then we can look at it and verify. So I mean, there's lots of work involved in talking to them, but it's important to sort of to be strict, but also to be fair. Yeah.
Have you had to change your definition of a bad worker?
Not directly. Like we didn't make any code changes yet. But we definitely started thinking about workers differently. So we still like the rules for like who to allow to work and like how to prioritize who gets work. They're still the same, but we are now doing a better like part of the training is also evaluation. And with our new training, we have a better way of giving people sort of checking tasks, and from that computing reputation, and from that we'll be able, like we have a new way of evaluating goodness, but we're not using it yet because we still need some pieces to fall in place. But yeah, it's definitely a working process. Yeah.
I was also interested, do the workers know that they're being monitored?
Sure. Yeah, so there's like a Facebook group where a bunch of workers are there with some of our community managers, and they talk to each other. And I mean, even before we told them, they figured out this stuff because they're pretty nifty.
Do you find that there are actually more bad test cases than there are bad tests?
I wouldn't say there's more, but it's definitely a big concern. Writing good tests is an art, and it's something that we have a pretty big sort of customer success story going on, because we need to work with our customers and teach them how to do the right thing. If you write it's just like classification. If you give it bad data, it will get rubbish results, and if you write your test badly, you'll get rubbish results as well. So it is very important. Yep.
So you talk about the state, but is there any carrot to sort of like, is there any incentive for a worker to be a good worker?
Right.
The first question. The second question is, have you tried and ruled out something like completely counterintuitive, like maybe paying them more? Why would that work?
Sure. So to answer the first question, no, there isn't yet, but we're working on it. So we have to be careful, because we don't want to encourage people to try to, for example, keep finding new bugs. If we started paying them like a bonus every time they find a bug, they might just find spurious bugs that our customers don't want to see. And if you put rainforest in as part of your continuous delivery thing, having bugs is really, I mean, it's better than not finding bugs, but having spurious bugs is also really annoying, because then you have to restart your build and delays the release. So it's a very delicate balance, but we definitely want to do something with rewarding workers who we know are good and who we trust. And the second, sorry, what was the second question?
Oh yeah, so it's about like, have you tried like maybe paying them?
Oh, right. Yeah, so we're also experimenting with different payments. Yeah.
Okay, so if there's more questions, let's thank Maciej.
Thank you so much.